You guys are at the top of the core too. These two guys are hard to define because they wear so many hats and are so multi-talented. Doug wears most of the hats. So I'll let them talk about all of the amazing things that they do and let you try to figure out how to put that in 1 or 2 words. But some of the words we were throwing on just now were kind of geeks, technologists, artists, professors. They wear all of those hats and more. A couple of quick announcements. If you're going to submit anything to the DSSG dictionary GitHub repo, do it by the end of the day today. Some awesome questions are happening, so we're excited about that. Awesome job yesterday, everyone, on your pitches. So without further ado, let's jump into it. Thanks, Matt.
Okay, so I'm Douglas Pancoast. I teach in the Department of Architecture, Interior Architecture, and Design Objects at the School of the Art Institute. I'm a professor of architecture. And this guy is?
Robb Drinkwater. I'm also a professor at the school. I'm kind of doing some boundary crossing, moving from one department to relate to art and technology, but I started working with Douglas over in architecture and sort of where he's working.
Yeah, so we've been collaborating for a few years now. And we've come today just to show you some projects that have come out of our departments and our school that probably in one way or another are related to the things that you think about and do here this summer. I think, for us, data and technical processes and computation has been an interesting context for art and design project making for a long time. So we're just going to show you some things that have come out of that way of thinking and informally, and we'll kind of see where it goes. So, like I said, we're from the SAIC, which is just right down the street on Michigan Avenue. We think about things, we have certain values, we write about our values, so on the screen now are some of the things that we think help us define who we are. The one that Rob and I like the most, I think, is this idea that meaning and making are inseparable, so we like to come up with projects where the production of some sort of working prototype, even at the expense of like really fantastic scope, is the way that we work. We like to make things that actually kind of work and are interactive and provide the context for ideas to happen. So we kind of think and we do stuff while we're considering the idea space that we're operating in. And all the projects we'll kind of take a look at today have got that sensibility at play. So at least for me, when I think about architecture and people and environments, for a long time now, I think it's been kind of common in architectural discourse to think about buildings as systems themselves. They are interfaces to other things, and to add the idea of data, that a building is meant to be an interface to information that can be unitized as elements of data, or quantum measurement comes into play, and we can use the interaction in buildings to think about how they ought to work and how they should be efficient and how they aggregate into cities. Talk louder? Yeah, I get that a lot. Yeah. So I'll try to speak up. So that's it's something that we've considered in architecture for a while now, building as an interface to something else. And so I think that in object making and art discourses and practices is becoming pretty common too. So we think a lot about what are objects and behaviors in places, how do they work, what is the role of computational processes and computational tools, data and its aggregation and its activation in what we do. So the 3.5 projects that we'll take a look at today kind of show technical processes and data collection happening in kind of the project framework in a different way. The first one kind of shows data and sensing and information collecting as a part of the project, but not explicit. It's not something that the user or somebody kind of looking at the project is meant to really understand, other than how data is used to kind of keep some system going. The next project, data and its visualization becomes kind of an active part of an environment, and then in the third project, data and its collection really becomes the central element in the project. So I'm just going to jump in, and Rob is going to jump in as well. This first thing is a robot project that we call the Bovat. It's a tumbling robotic agricultural agent. It was a project framework for thinking about all sorts of ideas related to land use and agriculture and technology and how people occupy environments of industrial agricultural production and what might be a collection of interesting tools that you might find in that environment to both reveal how it works but also maybe provide for some sort of efficiency in that environment. So from the beginning it was the idea was to make a robot that could live comfortably within a production agricultural environment and do things that we think are kind of interesting. And then along the way, use it as the opportunity to pick up some interesting skills and technology. So weren't exactly sure what the Bobot object was going to be, but we knew that we could probably use the software that we understood at the time to kind of prototype and begin to visualize certain kinds of activities. Production agriculture is a really interesting, fraught with problems as well. A framework for land use. You got to kind of embed the landscape with machinery to make it efficient in such a way that you can justify the processes that happen there. So thus the robot. We used software, Flash, and ActionScript to begin to kind of prototype and visualize the way in which an environment and a robot could kind of interact with one another. So for example, here's a little Flash piece that we made to just try to get our hands around, at least within the scripting environment, how a robot could potentially act as a herder. Could we put an object out in an environment and without fences and center pivot, irrigation systems and ways of kind of using the land that might be contrary to the way in which it is ultimately most efficient. Could a tumbling robotic agent do this? Herd cattle? Could it be going to understand and move around the landscape, thereby mitigating the effect of like large feedlots and that kind of land use? And so if we feel like we could kind of understand and produce a kind of movement, in software, maybe we could then port that over to our robotic device. So this robotic device, maybe it's a herder for cattle, maybe it's a light that could kind of tumble around the prairie and help you find your way at night. It could potentially be something that would seed overgrazed areas and allow kind of indigenous grasses to come back. Trying to find that relationship between a mechanical object and a natural environment that, in a way that produced the kind of balance that was effective. Yeah.
Is this robot doing sort of a random walk?
Yeah, so at the time we just wanted to make something that could move, that could tumble around. So we looked at environmental objects that are common on the prairie, like tumbleweed, and modeled a kind of a movement, after that. And we felt like if we could get something to move around, understood that it was moving, knew that it had stopped, had the potential to potentially kind of roll in one direction, not necessarily pick a place on the horizon and navigate there, but just kind of move around, because we kind of assumed that if there was a network of these things, that they could have the right kind of coverage. They wouldn't necessarily have to be smart enough to pick a location and move there. They could kind of operate within a network, and the network would have the intelligence and not necessarily any individual agent. Some of the projects that we're showing today, it's kind of an important part of at least the practices that Rob and I participate in and collaborate in, is trying to find a way to build every element, right? To design all the software, to build all the systems, to make the objects, to consider the environment as much as we can. And we kind of use collaboration as a way to not divest and bring skill in that we don't have, but connect with other people that have skills so that we could potentially have a part of it as well. And then we can go back out into our practices with a little bit more facility. So making the robot was something that we undertook. So the simple idea was just a sphere that was made out of machined, milled aluminum parts. It moved on the simple principle of extending and retracting piston weights. So if you have a sphere and you put a weight on one side, it's going to roll towards that side. That's it. If you retract the weight, it's going to want to find an equilibrium. And so the robot consisted of an aluminum sphere with a skin on the outside and 6 protruding weight piston elements. Simple little motor, wasn't a servo, wasn't a stepper motor, just a simple DC motor that went out and went in. And at the time, this was pre-Arduino, right? So we had to kind of learn how to program PICs to do it. Also, we kind of assumed that that even though our prototype might be this big, that the actual object out there in the field would be much bigger. So, we took the opportunity to kind of go out to the prairie and prototype large objects and to really try to figure out how they would tumble around the environment. What were the kinds of things that they would have to move over, like, tall wheatgrass, roll down hills? Could they be light enough to just carry into place and then turn them on and let them do their thing? So prototyping at various scales was something that we thought about. That's just a simple shape prototype that existed out in rural Kansas, where we kind of familiarize ourselves with. And then there was also the problem of thinking about and designing the relationship between all the electronic components to make those motors move in the way that we thought about. Thinking about different ways of networking the control of the sensors and the motors together to produce the kind of system that was simple enough for us to work with, but then also robust enough to be real. We ended up going with kind of a really simple system where there's 2 PICs that listen to 6 PICs, and each one of these PIC chips then listen to 4 individual just push-button switches like this, and they were arrayed around the skin of the robot like that, so that as it tumbled, it would always want to find a flat spot. If you take a sphere and roll it, it's going to stop on the spot that is flat. And once it stops on that spot that is flat and you put a sensor there, then you know that the robot is stopped, you know what side it's stopped on, you know the orientation of all the other pistons and all the other sensors relative to that stopped position, and you can fire pistons in such a way to get it rolling in one direction or the other. So we've used SAC facilities to cut forms for molded plastic to make the skin and to wire everything up, and we ended up with something that looked like that. It rolled. And so, we turned it on and it rolled around. Yeah.
Can you just tell us, because you showed something that was really big.
Yeah.
I can't get from that. Like, was it a soccer ball size?
It's 2 feet in diameter. So this prototype is small because it had to be small enough for us to work with, to carry around. It's battery powered as well, right? So the motors were the small DC motors, and they would have to be, they couldn't consume, the kind of power. We didn't want to make something too big to actually work within the shop facilities and the spaces that we had at our disposal. So, but a lot of the principles, a sphere is kind of a sphere no matter how big it is, right? So the principle of extending a weight to move it works at almost any scale. And so we felt like if we could prototype at one scale, it would be applicable on another scale. The idea that we never were going to go into production and make, we weren't going to contact John Deere and say we've got this idea about a robot and you should partner with us and make this thing, was not something that ever really limited the thinking of the project. And it actually allowed us to kind of like be a little bit freer and kind of prototype and make things much quicker, because there wasn't the idea that it didn't have to conform to all the ideas of usefulness and efficiency. Just getting a robot to move around in the way that we could predict with this idea, to keep the discussion about what is that place like and what kind of machine could exist comfortably there was the nature of this project. Couple more images. Okay, moving on to the next one. So that project just it came out of our personal practices. The next few projects came out of classes that Rob and I co-taught at the SAIC. This next one is called the Loom Project. It was an installation, an environment that we made for the International Contemporary Furniture Fair, which is a large trade show of architectural systems and design systems that happens in New York City every year. It's akin to like Salon de Mobile or Neocon, that kind of thing. So vendors come there and then they kind of display their wares. The ICFF organizers always reserve spaces for schools to come and build something. There's a competitive process to describe what you might do. So we responded, we were selected, and we decided to make this thing that we called the Loom. So what the Loom was, it came out of a studio that we cobbled around this opportunity, a special project studio. We knew going in that it was going to be kind of a design build studio, that we would make something, we would make the components ourselves, and we would install the components at the ICFF site. ourselves, and the students would all collaborate to make a single environment, as opposed to what is common in a lot of design and art studios, where students might be examining like a core set of ideas, but they maintain their own practices and their own projects, and they might not be connected to one another. So this was kind of a collaborative endeavor from the get-go. And the idea that we had was that we would make an environment, because it's a trade show, which is the way in which design and architecture industries connect with commodity. There was going to be a lot of buying and selling and the discussion of products and their value being how sellable or how attractive they were as a unit of design. We thought we would go there, and as opposed to sell something, we would give something away. That was our idea. We would vend gifts, free objects. And so the challenge became to create an environment that was all about that through all of the different hierarchy of detail in environment making and object making. So the loom was for that. The gift object that we were going to vend is a small Tyvek bag that you could put all the other crap that you get at these kinds of trade shows in and carry it around. And then, so we would basically, subsume all of that other crap into our bag. The bag itself would be the identifying element of our project. And so we wanted to make the manufacture of that bag, the cutting of the bag, the tying up of the bag, giving it to the person that came to our environment be performative and quite visible and interesting to look at. So that's what this environment was. So one elevation of the environment, you can kind of see it here, well actually snaking through the environment was this collection of Tyvek tubes that students would cut in situ, a bag shape, and tie it up and give it to you. There was 4 possible bag designs pre-printed into the Tyvek tubes that, depending on how the students cut, they could tie it up and make like a shoulder bag that slung this way, or maybe it slung that way, or maybe it was like a backpack. And so it wasn't just one bag object, there was multiple bag objects, and depending on which ones the students were cutting, that's the one that you would take away. So integrated into this environment was all the elements of that gift vending. And so one thing that we were kind of concerned about was giving away, so the ICFF event was going to last for 4 days. And we had about 5,000 bags on our rolls and rolled through our environment. And we didn't want to give away too many bags on one day so that we would run out of bags by the end. So we had to pace ourselves. We could only give away a certain number of bags. And the way the system worked was kind of like this. So each one of these these moving elements represents one rack of bags that was integrated into our piece. So when you looked at our piece from across the Graphic Center, Exhibition Center, you would see the elevation that would move like this. There's people pulling bags through, cutting them, pulling them onto to a cutting station, cutting them away, and giving them away. So that kind of movement, it was a kind of a low, it was literally it's just the kinetic moving the bag through the rack was what caused visibility to happen. But this is what we were concerned about. This, running out of bags on one side, or prematurely, so that the elevation was compromised. So we had to figure out a way to pace ourselves. So running along one side of the bag object was a simple black and white printed pattern that was connected to a system for sensing the movement of the bag and counting it. Just come back to here, sorry, I'm kind of jumping around maybe here. So, here's a student pulling the bag through to a cutting station, using a roll cutter to cut it, tying it up into one of 4 shapes, and giving it away. All right, so it's literally kind of like a barcode that has been printed on this side. It had, as opposed to having some sort of aesthetic value, it also had a data value. Right. And so a visualization like this was playing on a nearby monitor that students could look at that helped them understood the way, the pace of the bag vending. So kind of worked like this. So every once in a while, you'd glance over there, and there was one little box spewer that was related to a rack of bags. If you looked over at the screen and you saw, that screen full of elements, that meant that you had vended a lot of bags in the last 5 minutes. If you looked over at the screen and it looked like that, and there weren't a lot of little square elements that had been written to the screen, then you knew that you could pick up the pace. And so this is a project where counting the number of bags, recording it as a unit of data, and visualizing it was really integrated into the entire operation of the environment. So whereas the last project, the fact that the bot might have landed on a side and that could be sensed and counted and then fed back into the system for moving the robot, the data wasn't really explicit. This one is much more explicit, although it's not being logged, right? So it's just being used to kind of determine and help throttle the piece, but it never really produced a set that could again go back. We could use it in any other way. Back to this. Questions? Yeah.
Why did you decide to display the data in that visual way as opposed to maybe a counter saying how many bags have been displaced this morning?
Well, we wanted, that's a good question. We wanted people to be looking at a single visualization so that visitors and the people that, and us, the people that actually were working in the environment, will be participating in the same visualization, as opposed to having some sort of counter or some sort of interface that was only specific to the cutter. So there was something about the experience, the social experience of having everybody kind of participating in the understanding and the legibility of the data that was just valuable to us. Also, if we had a counter per rack, it could be counting, right? There could be another counter going on over here, but then somebody would have to understand and correlate the number of bags that would be vending through any individual rack. So this is a way to see all of them at the same time, right? Another thing that would happen in this visualization that I didn't bring today was that if a lot of bags were coming through a particular rack, down here at the bottom, the visualization would indicate to you that stop cutting bags from rack number 7 and move to rack number 1. Now, also, you could just look as well, because down at the bottom, the roll of bags that fed the elevation, it would literally would get smaller as you were using them. But by the time it got small enough to recognize, it might be too late to pace yourself and move to another rack. So the system that we used for this was a little kludgy, but in the end of the day, it was really kind of simple. We had a little PIC microcontroller that had an infrared sensor on it that was trained on this black and white pattern, which was communicating to a computer that was running Director, remember the program Director? And so Director was helping us process all that information, and then that was interfacing to a flash piece that was actually producing the floating square visualization on the screen. And it worked really pretty well. So we went to ICFF, we made the thing, and it was fantastic. The discussion around what the design element was, we thought was really delicious. People were like, well, what is the thing? Is it the whole environment? Is that what I'm meant to think and talk about? Because usually when you go to ICFF or those kind of things, it's like there's a booth with a chair. It's like there's the design, there's the chair, cover the chair. But in our piece, it was like, was it the whole environment? Was it the bag? Is the bag the design thing? Was it the system that was counting the bag? Was it the visualization? Was it the furniture objects that we had around them that we had made that were kind of integrated into the thing? So
the social performance of cutting the bag.
Exactly. So that ambiguity we felt was really interesting and kind of a success, where all the elements of the project were supporting one another. None seemed to be more important than the other, and then, it produced a kind of an interest. And so by the end of the event, the queue of people that lined up to want to go through, and maybe it's because we were giving away free stuff, but it doesn't really matter. So to talk to our designers, to ask them about what they felt was valuable in design and how the piece worked, was a really interesting experience. And the design, the student designers that worked on it, I think consider that a really successful project in their history of project making, because we had to, everybody got a little bit better at all of the elements of producing an integrated design environment like this, because of the pressure of producing something that had to perform and be real. Okay, moving along. Rob and I co-taught another class called Interface Reconsidered just last year. This class in particular was, we wanted to focus on interfaces. Interfaces, that thing that sits between like maybe your body and, appliance that you're using, your body in the city, a building, city, a building in another building. So we just kind of wanted to unpack and explore the idea of interface. We were particularly interested in interfaces that engage the body and its full physicality, perceptual ability, kind of in an urban context to really think about how you're interacting with some system by using an interface. Students in that studio did all develop their own project, but we also had kind of a collective project that came out of that as well, which we'll talk about in a second. Part of that class was teaching students how to make an interface of some sort using technology in some way. And so for us, the Arduino microcontroller became kind of a natural thing to do. That it's a fantastic open source system where without knowing a lot about what's going on under the hood, you can connect an input to the microcontroller and you can get some sort of output response, and then from that kind of input process output, you can begin to build really interesting interfaces. It's cheap, it's easy to get, there's a really big, robust collection of users out there using the Arduino system. Students aren't afraid of it, quite the opposite. They know if they're thinking about adding that kind of technological ability to their art practices, even if they are not kind of technologically inclined. You can connect an Arduino to a screen via processing and get immediate feedback about what's happening and kind of the information that you're collecting about environmental conditions, in a couple of minutes. Yeah.
What kind of sensor do you think you hook up with?
Man, it's
Douglas has a matrix. Of
you can connect.
color sensor.
Yeah. We walk around with sensors in our pockets, you can see. Yeah. It's wow. It's like I think about categories of sensors now because there's so many interesting transducing devices that are available now through really accessible vendors like Sparkfun or Adafruit or JP Marlin. You can connect sensors that temperature, air quality, humidity, vibration, barometric pressure, moisture, content, color.
Stopping right there.
But on and on. And every week there's something new. I mean, these sensors have been around for a long time, but I think what's happening now is that they're being shaped and commoditized and delivered via an intermediary layer of kind of breakout board technology to make them really interesting and to work with and easy to interface to the microcontroller of your choice, which happens to be the Arduino for a lot of people. Now a microcontroller is a little computer, right? It's a device that has processing power built in. It has inputs and it has the ability to communicate to some form of output. An output could be a motor. An output could be something that logs your data. An output could be an LED light. They could be combinations of all of those things. Rob and I are at the point now where logging data and figuring out a way to log data quickly and efficiently, wirelessly or in situ is something that's kind of what we're thinking about more. There aren't as many cheap and really easy to use systems for recording the data that you can collect with your microcontroller. I mean, you can, but it's a couple of months away to maybe it can be a little bit easier. So we think about that a lot, logging data. So out of this class, we put it to the students in the beginning of the class that by the end of the class, we wanted them to kind of, as they were developing their individual projects, to also work with one another to produce a collective project that the studio worked on together. And so we did a little bit of brainstorming. We came up with the idea of making a really, as simple as we could, little sensing moat. We called it a moat that you could attach to your bicycle for collecting environmental data when you ride your bike around the city. That idea is not really envelope expanding. There's been all sorts of accessible, open source, affordable, quantified self, personal self kind of sensing systems that have been available and been out there for a while. But it was something that our students had done. And that, back to this idea of making something to understand its value, to kind of derive its meaning, and then from that going back to the making, that was the value of that, coming up with a a bicycle-mounted sensor. We eventually started calling this project the Mote O-Bike. Mote is just a word that you kind of find out there in the world of Arduino using that just means sensor, small sensor. And so the Moto Bike is a mote that you put on a bike. And we thought that it would be nice to collect air quality information, temperature and humidity, potentially information about GPS, so location, light, sound. We kind of vetted all of these things, and we eventually came up with a mote that did just about all of that. Just about. So, you know, when you put these things together, and you make a little technology, you know, what's interesting to us is not so much solving the gadget problem. That's fun if you like technology, but it's also thinking about if you're making a platform using that technology for people to go do something and you're recording information about it. There's real value there in the discussion and the ideas that you begin to kind of recreate. You know, what kind of information would be useful? We're essentially creating a kind of a surveillance device. What's that all about? You know, what if you instrument, you know, the world with devices that are collecting information about how things are working? What kind of delicious discussions might you have about privacy and the definition of public and who owns the data and what do you do with the data? How much data do you collect? Is today's noise tomorrow's data? Maybe. And so those kinds of discussions in the group board is interesting as just coming up with a way to figure out the hardware and the software issues to make a mote that worked. So this was the idea. You know, all of our students, you know, at one point in their life or another, are whoa! That's okay. Everything's fine. Are bicycle bound. So there's people out there on their bikes, going on runs, taking routes through the city all the time. We thought we could instrument that. Oh, look, you got food on our boat. So if we could, you know,
Unforeseen environmental conditions.
that's right. Is there a Tzatziki sensor on there? So if we could instrument bikes such that we could, you know, collect a lot of information, environmental information about the city, at some point that data itself could be a resource. That it doesn't necessarily make any difference that it isn't about the bicycle anymore. It's about the available you know, set of information that you could begin to glean from the world from available data. And that's kind of like, you know, maybe a bigger goal. So this is the very first mote we made. We just, you know, used the Arduino and components that were functional, but, you know, kind of rubber banded together, and we strapped it to the bike. And we started going on rides. And the original mote collected information about, well, it recorded the ID of the mote itself, the run number, the date, and the time. There's a GPS module on there, so we collected information about latitude and longitude. Also, altitude, Z, although that's really not so reliable, you know.
Chicago's not so good.
Yeah, because there isn't a lot of Z change. You know, from the GPS information, we could derive things like bearing and your average speed, miles per hour, things like that. There's also an onboard air quality sensor, and a temperature and humidity sensor, and a light sensor. So every 15 seconds or so, yeah, we could log information about what was going on in your ride. And we made a few of them, and we gave them to students, and off they went. They began collecting information about, or I should say, data about their rides. And then since then, that was last year, the project has just kind of stayed alive. You know, people on their own have been developing more robust cases for the same kind of really readily available and cheap Arduino-based microcontroller hardware. So this is a little case that I made to just shield that mote, so it made it easier to connect to my bike. I could, you know, throw it in my backpack and it wouldn't fall apart. It's battery powered, so the battery comes out, you recharge it, and you put it back in, and it lasts long enough for a few rides. This is what the data looks like. We just collect the data and save it as a text file. So information about the ID of the mote, the date, all of these numbers correlate to information about light, humidity, and air quality, and so forth. And it just logs it. When we get a big old text file, it just, you know, starts at a particular time and it ends at another time. and that data is logged. Yeah.
Maybe you're about to get into this, but
Yeah.
how are you storing it? I know arguments with pretty low capacity when you're not generating that much.
Good question.
Or do you have to think about how you structured it to save space? Or?
2 gig SD card.
Okay.
It's got a little micro SD card. So there's a little bit of EEPROM memory that you can write to, but it's tiny, you know. And this, you know, for the Arduino, the sketch that we wrote to drive it was starting to get pretty big. It was taking up most of the memory. So we just put a little onboard SD card. And for the time, just to kind of make something that worked, the little SD card is fine. So the text file gets logged, you take the thing out, you put it in an adapter, you put it in your computer, you add the text file, and then you do something with it. At the time, Rob also built a high-functioning but really simple website for receiving that data and just producing a really simple Google Maps visualization of where the run was and kind of displaying information about what all the different data categories were. But now kind of switching gears, so that project kind of stayed alive, and it was taken up by a student that took that old class, but then was also taking a new class that Rob and I just co-taught that just ended a few weeks ago, the Jeffrey Studio, whose work is exhibited right now over at the SAC Gallery. So a student kind of kept working on the motorbike project and just took it a little bit further. So now we've got is, let me see if I can look and see, yeah, there it is. So kind of a friend of this group, Derek Eater, collaborated with us, helped the student design and build kind of a back-end website for receiving all of the data, keeping it, allowing you to kind of see it, interact with a dashboard, basically, for the data. So this is just a typical, this is where I live. So this is my typical run from where I live down to the loop and then back. Information about how the air quality changed, the temperature, how the temperature changed, humidity, so on and so forth, the dip. This is you?
This is my living room.
Yeah. This is walking around this living room.
Derek said, it's not going anywhere. It's like it was just sitting there. Doing some test programming. I didn't realize what data set I gave you.
So the Jeffrey Studio is another kind of collaborative design studio where students looked at data and data collection as the primary element for art and design project contexts. Right? And out of that came a lot of interesting projects, and one of them was the continuation of the motorbike project. So this site now is out there, it's live. We're going to kind of go back and we're going to continue to work on the hardware elements. The student that worked on the motorbike project this semester designed a different kind of case enclosure for similar components, but smaller components that would connect to the bicycle handlebars in a different way. In a different way, in a better way. So this was this is like version 2. This is like version 3. And this is where it is now. So this is a part that we machined ourselves in our shop out of high-density polyethylene plastic. We can produce this really pretty cheaply. We're going to make enough of these units to put a few of them in the school's media centers and libraries, and invite students to check them out, go on runs, collect data, use the site to kind of to record the information about their runs, so that maybe we can produce that kind of resource, that data resource about city activity, environmental information that we thought we could. So by the fall, there'll be enough of these out at least in the SAC and our student community, to begin building a thicket of data. Other projects, let's come back to...
Have you thought of making it available to the public?
Yeah, I mean, everything about the project has been kind of open. It's like owned by everybody in the group, but then everybody else.
Can we buy those? Can we get those?
You definitely could. I mean, the thing that Rob and I are thinking about now is just describing the project, diagramming and componentizing it so that it could be a kit that you can buy and put together, right? So that as technology changes, as the code changes and gets better, as the website improves, you can continue to participate, but you have the ability to kind of update the mode yourself. Right now, I mean, these components, kind of an unfortunate condition of being easy to use is that sometimes components are expensive. Like when you buy one air quality sensor, it's expensive. When you buy 10,000 of them, it's not that expensive. So if like this would cost maybe $120, that's kind of expensive, right? But if we could, as we continue to work on and most likely design our own custom printed circuit board with, at a higher quantity and pre-manufactured and soldered components, we can get the price down to a point where somebody can buy the kits, or, so you can do it yourself.
Have you thought of doing a Kickstarter?
Thought about it? Yeah. I mean, as we make versions, we give away the old versions to people that want them, and it's always really interesting to have that happen and see people use them and see the data come rolling in.
Is there a mailing list for discarded versions?
There aren't that many.
There's only
and some of them,
three,
unfortunately, be cannibalized for their future offspring.
Right.
The other thing, though, that Douglas didn't point out on the website is that it's all the data itself is also available. So it's a sort of a pre-version at this point, but you can click and download the CSV file of any of the data that's up there. So if you want that data from Douglas's run, it's there for the taking, and it's part of the sort of ethos of the project is that everything is open.
The light and the air sensor data would be really, really interesting.
Yeah.
There's like 2,000 of these on the screen, right?
Yeah.
That's
Yeah.
Yeah.
Oh, I got a question for you guys. If we're ready for asking like a question that's not missed.
Sure.
So, you're an architect, and you're a sculptor, right?
No, but
I was misinformed.
I'm an artist. Just leave it at that.
So you guys come from art and design,
Mhm.
where the objective is very different from the more kind of engineering work that we do. Where engineering work try to solve problems, artists will try to
Make problems.
depth of the human spirit, and then designers are sort of in between in a way. Like they're also actually really problem oriented, but they use kind of the creativity of artists to resolve solutions. A lot of this has kind of data as an ingredient in there, and you and I have talked a lot. So here we talk a lot about if you don't start kind of using data as a resource for solving a problem, for us to solve social problems. You often say that you're thinking about using data as a material.
Yeah.
So you talk a little bit about like how that works and how you're thinking about this concept of data as a material in kind of more art service applications.
Yeah, I mean, so I'm a professor of architecture. I mean, I teach architecture. I like buildings. I have an architecture building making small practice. And, making and conceiving and delivering a built environment consists of understanding and kind of aggregating lots of overlapping systems. The structural system, the finish system, the light and mechanical system, programming the building so that people can use it and move through it in the right way. So, I think it's not that much of a stretch to consider what we can understand about a building through data collection as being yet another layer, another system that can be integrated into at least the architectural design process. It's not uncommon for architects to really understand the value of research, and we want to understand the way that the world works, the way sites work, the way human beings interact with one another, so we can make environments that have value, that are lasting and are persistent and efficient. And so I think when you add data to that enterprise, it's really quite natural to think of it as another material, something that you have to be, think about learning how to represent a building's form as something that requires facility and skill that you develop over time. I think that working with data is the same way. Understanding how to measure something, how to record the measure, the value of it, going into the process of making data facile is something that art and design should do. And we should take that up as another opportunity to become skillful in a media or material. What do you think?
One thing we've been talking about this past year is that, because of this ethos of making, one of the curious things I think is a little bit different from us, from you guys, is that you're often using data sets that you acquire from other places, or other people acquire and give them to you. For artists, it's interesting to think about, we're data makers. We're interested in making the object that collects the data and then taking the data and doing something with that as well. So it's a sort of full circle type of idea. We're just trying to get that idea and that ethos sort of rolling in the art school. I mean, this is fairly new for art practice, and we're sort of, Douglas and I are having fun sort of pushing this boundary and asking exactly questions like that. So we don't seem to have a clear answer. It's because we're still exploring what we think is just this very sort of rich.
It's interesting that instead of sitting around and talking about it, it seems like you guys have done about this investigation by like making little things.
Yeah.
Can you talk about why you work that way?
I think that that's just kind of an atavistic connection to art making. I mean, the idea that you go into a project with the idea that out the other side is going to be a thing, a painting, a sculpture, a delivered architectural environment, a unit of industrial design, that something's going to come out of it. I mean, I think that research and contemplation and thinking about all the elements of a project in order to enable some process that makes something is just kind of part of art and design. And so I think that a lot of that is that's just how we were trained, this is how we think. You know, and so it's just going to be the way that we work.
Well, what is the process of figuring out how to make a thing and then the final thing?
Yeah.
Do those actually inform these larger kind of debates and investigations like that? Like, is that a useful way of actually doing research?
I think so. I mean, it's you know, it's a kind of field research. It's situated research. It's being responsive to the way in which the conditions of the project change. That creates a different kind of project, which adds new ideas to the project, which makes the project go into a different direction. So I think that, you know, for a while, I think that, you know, in the projects that Rob and I kind of participate in, there was this desire, particularly when the subject seemed to be the relationship between art and science, for us to really define the difference between art processes, design processes, and science and research processes. Now we're not so concerned about kind of coming up with a nice, clear philosophical classification for the difference between those enterprises, and we're more concerned with producing really interesting prototypical projects where all of those things are at play, and we'll see what we get. And then we can take a step back and we see where the project goes, and then we do it again. I mean, here I'm just going to show you a couple more projects that came out of the Jeffrey Studio. So this was a project where a student wanted to map how and where a small Gerber daisy seed bomb object that she made would be distributed through an environment. So she made this project where she encapsulated Gerber daisies into a little tiny seed object. She encapsulated those seed objects into this delivery system. She gave them away to stores and vendors all over Chicago, and then she invited people with a little QR code on the box to plant the Gerber daisy and then map where that daisy is. All right, so this website and project just launched a couple days ago, and we're starting to see those Gerber daisies that she wants people to plant out there in the environment collected and mapped in this site. Here's another project came out of that studio called the Microboundaries Project. These two students collaborated. They were really interested in how the city is an environment for people, sure, but it's also an environment for all sorts of other things like beneficial microbacteria. So the game that they invite you to play is to be really sensitive as you're walking around the city to look for places that are conducive for certain kinds of microorganisms, right? So a certain kind of light, a certain kind of moisture condition, a certain kind of shade, you know, causes these particular bacteria to grow. And when you see that environment, take a picture of it, right? And then upload information about the place of that microenvironment to this website so that a map about where these microbacteria or these bacteria might be growing could be collected and then eventually could become stored on some sort of resource.
Seriousness, this is a game.
Yeah.
This is considered at the level of play. So this was another one of those sort of investigations. It's not science, it's scientific type information, but it's like you play, the way you play the game is you choose a bacteria, and if you find a successful place for it, then you get to choose another one. And so there's a leaderboard, and there are people sort of competing with each other to sort of populate the city with these would-be bacteria. And so it's play. Yeah.
So, I was going to ask you about how much both the city of Chicago influences your art, and also it seemed like maybe there was some political element. I mean, it was kind of interesting that you went to that show and gave stuff away.
Yeah.
Where it's like this massive consumption. And so I kind of thought that was kind of subversive in a nice way. And so I was curious about, both Chicago, which has really sort of stark boundaries, architecturally and neighborhood-wise, and some of the political stuff, if you can talk about that.
That's a great question. And the longer I live in Chicago, the more Chicago becomes subject matter in my work. So thinking about the relationship between the city that we can experience as a physical environment, buildings out there in the city, to the sociological environment. So looking for opportunities to make disparity evident, to bring awareness to the way in which the city actually operates, maybe different from a political definition, is subject matter that we constantly go back to. Also, cities are the most amazing invention that we've ever come up with. They are kind of the source of just about all of our creativity and potential. I think if we're going to kind of settle the planet in a way that provides for our own existence, we got to really think about cities and density and the way that they're going to be designed in the future. And so just in terms of pretty straightforward architectural discourses, that the city is something that is really becoming fascinating to re-examine now in architecture. And so we do that as well. And as far as the subversive component,
Just comes with the territory.
I was on the tenure track, so I had to make sure that that we were investigating and using ideas in a way that was really interesting. So this last project,
I thought just add a little bit more. Is that there is this interesting freedom in being an artist that you sort of get to play both ways. I mean, we're also aware of the very sort of serious connotations of the Moonlight project. I mean, it's air quality. We're sort of relishing the moment when it starts backfiring. So that'll be interesting. We'd like to see it in a little bit of waves. And we were just on the way over discussing some of the implications. Like someone asked about getting this thing more public. We'd love to get them on the bike shares. We went past one of the bike share racks. We were talking about doing that.
Yeah.
But of course, one of the things we're really aware in that particular project is if we just slap this thing on a bike and GPS log it, and you get off that bike and say, wait, you did what? So we're talking about like the social
imprisoned me all over the city.
Exactly. So then, as artists, our response is like, great. Then what we're going to do is we're going to paint half the bikes bright green. And only those bikes have on it. And there's going to be big printed matter that says, "Participate. Help us with this. It's a citizen science." Small type says Andrew B. Catalog. But those are we can play. I think sometimes a little fast and loose with those. It's not that we're not cognizant of it. It's sort of the nature of what we do to just be liberal about those ideas.
So another student that was in both the Interface Reconsidered class and in the latest Jeffrey studio, Miguel Perez, did this project. So Miguel is from Little Village, which is a neighborhood on Chicago's west side, on 26th Street and Kedzie, maybe? Yeah. And so he was really interested in and concerned about the air quality in Little Village because of a lot of the vestiges of kind of industrial activity that still
there's a coal fire
Yeah.
plant down there that's just being decommissioned. So he grew up in the shadow of that, and it has always had this suspicion that it has an effect on his loved ones.
Right.
Right.
What's that?
And two cold lights in the physical property.
Are there two? Miguel only talked about one, but there,
Promise wasn't to the village, this case in the center.
Ah, good to know.
But both as we close, we Crawford closed first, and then things close September.
So this was subject matter that was a part of Miguel's life as he grew up in that neighborhood, and he took it up in this class and developed his own air quality sensor, Arduino-based air quality sensor.
Can you pull up a map real quick so people know where it is?
Yes, I can.
We're still developing our model.
Actually, I wonder if there's one on. Might be one on Miguel's site. Let me check. No, there isn't.
That's also where the Cook County Jail is, by the way. That's an interesting place to go see.
I wonder if that's an accident. So there it is. So 26th Street is. Sure. More out. So you're here. Here's Little Village, Lawndale. 26th Street is the main drag through Little Village. So Miguel made his own air quality sensing moat. This one? Yeah.
Or actually, I guess a little bit.
So, I mean, this kid, man, he was such a rock star. So, I mean, he developed the sensor, he coded it, he learned how to design and produce and facilitate the production of printed circuit boards. He soldered them all together, he installed them in Little Village. He came up with the visualization software. I think he primarily worked in open frameworks, right?
Started processing.
Started processing and worked with open frameworks for producing visualizations about the air quality information that he collected. And then he took displays to Little Village community, elements, right? So shops and convenience stores and kitchens and friends' houses, and he installed these displays that were live, that collected and presented real data about air quality that was happening at the time. And this project now is also installed over in the gallery and continues to work. So the sensors are still out there in the world, and I assume that this project is going to be something that he sticks with for a long time.
He had resistance to people. I guess he probably approached a few people asking him to censor it, right? Did he get resistance towards that, or people saying, yeah, sure?
Oh, that's such a great question. I mean, that's something that as faculty that we cajoled him for a long time. It's like, you assume that you're going to be able to instrument the world and no one's going to push back, but you really have to kind of get out there and reconnect with your own community and let people know what you're doing. And so, he took the challenge, so he participated in a lot of kind of community organizing events. He went to the meetings, he had kind of understood who the stakeholders were. He went, introduced himself, and kind of became much more present and visible in the neighborhood, so that he could then bring up that subject about instrumenting their environment. So it became something that it became an element of the full delivery of this project that I'm not sure that he would have accounted for until we actually went to make it. Right? So the idea of meaning and making, affecting one another was really evident in that very thing. If this was an idea that was going to live on the whiteboard, he never would have, the imperative of really understanding the community issues and connecting with the people such that he had to do, probably wouldn't have been something that happened.
That's the same impulse that animated you guys. So go ahead and talk to these folks. Develop the project. You can come up with all kinds of cool things on a whiteboard, but maybe they're actually relevant once you talk to the person you want.
It's
Same basically.
These dashboard displays that he was taking out was this wonderful feedback loop, because he's going out and saying, I'm instrumenting your community, and then I'm putting that information presented right in the community. Come see it, come look at it. So he didn't get resistance, he got acceptance, because people are like, yeah, tell me more. I want to know about the air quality down in 26th Street. And I have one of those kiosks in my restaurant. So.
Good discussion. Any more questions? Yeah, what's up?
I was wondering if you could talk more about how you see yourselves in this intersection between art and technology and data. We're sort of all coming from the data side. I mean, like, how you artistic think with it, and that be the point.
Yeah.
And at the same time, it sounds like you guys are coming more from the architecture side and saying we can use technology and data to do interesting artistic things. And just where do you see this intersection going, and what's interesting about it to you?
I think that the intersection that you're talking about, I mean, it resides right within that area that we call culture, right? And so I think for us, we kind of consider ourselves as cultural agents. That's what we want to bring. We want to kind of culture. We want to try to find a way to apply and activate the ideas and technology in a culture, so we can get really interesting feedback and information about people and its use. So I think we reside in between art and science, or design and art and science, in that space that we just kind of like to think about as being related to culture and how people kind of interact with one another and begin to create the rule systems that they live by, and the objects that they value, and everything that defines, you know, a human being within a larger system. What do you think? I mean, I think that, you know, artists and designers deal with evidence. We make problems for ourselves. We solve those problems. There's a beginning, a middle, and an end. There's a resolution. We value and understand and apply research. I mean, a lot of the categories are the same. The way in which they kind of come together to make something that is resolved, that is legible and understandable might be different, but I think that we tend to think more about the similarity between a lot of the elements that come together to make new things in the world than we do their differences.
Hi. I have the unfortunate situation of working, teaching in a school that is a master's in a school of architecture, and there is this historic divide, both culturally, politically, distrust between the urban planners who see themselves as working sort of at the urban scale,
Yeah.
and the architects who sort of, you know, we think of them as working at the building scale and at the sort of, you know, cult of the individual rather than the good of the community. So if you could reflect on how you feel like architecture is beginning to address that urban scale, or if my problem is just a weird problem because it's...
You know, I understand that condition that you're talking about, and it still, unfortunately, is pretty common. I think that there's, I mean, I'm seeing a lot of interest in a different kind of urban research in architecture discourse that uses the kinds of tools and whatnot, and the kind of real kind of active or participatory methods. I don't know if it has a name yet, maybe somebody's named it, but it seems that there's a lot of architecture faculty and students that want to learn more about the larger context to inform the development of things that they're thinking about at the building scale. So they're just much more sensitive to the relationship between building and site or building and community. So we're kind of reclaiming, you know, a lot of the things that we read a long time ago, you know, Sennett and Jacobs and all those, to try to mine them for new ideas. You know, I think that, you know, another thing that makes me think about what you're asking is, you know, the role of interesting analytical computational tools in building making now. So it's really common for, you know, both in practice and in school for students to use, you know, pretty interesting and sophisticated parametric modeling tools where you're dealing with the information of a building as much as you are its form, right? And so if you're using a kind of a modeling environment where you can understand like the change in the environment's temperature and the way that that could be reflected into a kind of a performance in the building, you're already thinking more about the building as being embedded within some sort of larger system. So, I mean, I think that, you know, maybe through tool use, maybe through at the process level, you're starting to, there's connections being built between, you know, different scalar factors in the built environment, you know, from the human scale to the building scale to the environmental scale that maybe they're not quite as legible, but they're being made. And you know, I'm interested as an architect to see like who's going to come along and really wrap a really interesting you know, theory around that. How is that going to be theoretized?
Well, I mean, if that can be the language of discourse between planners and architects, then I don't have to walk on the hall sort of shooting.
Yeah.
You know, I mean, there's maybe a similar language and an approach because we're all reading Jacobs.
Yeah, right.
So that's, I see this really encouraging.
It, you know, is interesting to me. I teach in our MArch program at the SAIC, and I'm amazed at how much students want to develop projects that happen at the urban scale. I mean, it seems that we have to, which is not the way it always was, at least not the way when I was in school. I mean, we have to steer students back toward building scale. They're much more comfortable thinking about projects that happen at some like a landscape urbanism, like in that context, than they are about the building scale when they're kind of finally operating at thesis level work production, which I find just interesting. I never would have considered and tackled the the wicked problem of designing something that is meant to cover thousands of acres in a city and all the complexity that comes with that. But students are really taking up that challenge. They may not be doing it very well yet, but that's where their interests lie.
We are an open position to come up to
Back at you.
Great. This has been a really good hour, and you guys stick around for it?
Yeah, thank you.
If you guys want to smoke this beer, that was a metaphor for his wisdom. Then please do so. Otherwise, we're going to go do some work.
Get back to work.